Do you want to know how to keep track of whose turn it is and also how to save the king by slaying the queen? Watch this video to find out. Hello and welcome to part 29 of the series on how to create a chess game with ReactJS. What we want to do is we want to implement the same thing that we did with the opponent king. So as you can see right here, the opponent king cannot move to here, here or here because it's dangerous. We want to apply the same rules for our king because right now our king can still move everywhere. We are going to implement turns. Right now, white can move as many times as it likes, and black can also move as many times as it likes. Well, what we want to do is when we start a game, is we want white to be able to start, so black should not be able to move then. And once white has moved, white shouldn't be able to move because then it's black's turn. And then the turns switch. In order to realize this, we're going to open up our models and then inside of here our board.ts, and we're going to scroll to the top. Inside the board we are going to keep track of how many turns have been played in the game. So we're going to create a variable named totalTurns, which will be a number, and in the constructor this will be 0. This.totalTurns is equal to 0. Right now the red line is also gone. The red line was there because we need to assign a default value in the constructor. If we comment this out and we hover over the red line right here, it says the property totalTurns has no initializer and is definitely assigned in the constructor. So that's why we need to assign it a value. Well, it's fine because when we construct our board, we always have 0 turns, but we start the game on the first turn. So we always want to start on the first turn. What we also want to do is we want to add it as a property right here. So we say totalTurns, which is equal, or which is of type number. And then we want, instead of hard coding this to 1, we want to use the parameter that we get in the constructor. The reason why we are adding this to the constructor is because we are also constructing new boards. And when we construct a new board, it doesn't necessarily mean that we are starting over at turn 1 again. We might create a new board which is at turn 7 or turn 70 or turn 54. So that's why we need to be able to pass this in as a parameter. So now that we have added a new parameter to the constructor, we also need to update all the places where we call this constructor. So down here, we see that we clone a new board, and this board will also need to pass in the totalTurns parameter. And in order to do that, we just want to pass this.totalTurns in as a parameter for the new board.totalTurns. And I think we have made one mistake. We need to remove the last closing tag right here, and we need to add it here before the clone. So that way it will recognize our code. Otherwise we had a syntax error. I'm going to put this in a new line so we can read it better. And now we will have a number which is indicating how many turns we have played. So let's refresh this page. And then, well, instead of logging this to the console, let's go to our referee. And inside of our referee, we want to create a p tag right here with inside of this board.totalTurns. And now if we refresh this page, we should see a number saying how much turns we have played. In order for us to see the number of total turns on the page, we need to set it in the initial board as well. If we go to the referee and then all the way to the top right here, we see that the initial board is being imported from the constants. If we go to the constants right here, we see that we have a lot of red lines for the board, and that is because we also need to add the initial turn, total turn count right here. So, well, let's set it to 1 since we start at turn 1. And now if we refresh the page, we see the number 1 appearing on the top of the page. Great. Now for the tutorial's sake, we are going to style this and make it a little bit more readable. So I'm going to use an inline style right here, and it will have a color white. And then let's also give it font weight or font size of 24 pixels. Well, that's already a lot better. We could style this however you want, but now we can see what turn or how many turns we have played. All right, so if the first turn is the starting turn and white or the white team is the starting team, that means that all the uneven numbers are the numbers at which the white team can play. So let's create a comment right here. If we have turn 1, then white team is at play. Then if the white team has played, it becomes turn 2, then the black team is able to play. Then if it becomes turn 3, we switch again, it's the white team that's going to play. Turn 4, we switch again, and it's the black team. And that goes on and on and on. And what we can create out of this is an if statement. If the total turns count is an uneven number, so 1, 3, or 5, or 7, or 9, then the white team is able to play. If the total turn count is an even number, so that's 2, 4, 6, and an even number is divided, or is able to be divided by 2 in this case, then the black team is to play. So we can use this logic in order to deduce which team should be able to play. All right. In order for this to work, we need to prevent the board from playing when the current team is not the team that should be playing. So up here, where we play the move, we check if the piece, the played move is valid, and if it is not valid, we return false. Well, after this, or even before this, we want to check something else, and that is if the play piece .team is equal to team type.hour, then the board or the turn count should be equal to an uneven number, because our team type is white. So then the board total turns modulus 2 should be 1. All right, so what does this mean? I'm going to explain that in a little bit. Right now, we are going to say console.log valid turn, else if, no, it's fine. We are going to keep it like this. So right here, we are checking, okay, the piece that we are going to play, is it our piece? So for example, say this is the pawn that we are going to play, then this one will be true. So if we play this pawn, it will pass this statement. Then right here, we check for another thing, and that is, okay, let's take the variable board.totalTurns. And now let's do a modulus 2 on it. If the remainder of this statement is equal to 1, that means that it is a valid turn. So what does modulus 2 mean? Well, modulus 2 basically means if we have a number or total turns is equal to 9, if we do this modulus 2, then we will do 9 minus 2 minus 2 minus 2 minus 2. Is that correct? So this will become 7, this will become 5, 3, and 1. And the modulus operator subtracts numbers until it reaches the smallest number, which is 0 or greater. So this will result in 1. And if we do minus 2 once more, we get minus 1. So that means that 1 is our final answer. We could also change this with modulus 3. And what would happen then, I'm going to remove the 2's right here and the 1 as well, is we're going to do 9 minus 3, minus 3, minus 3. And this is equal to 0. If we were to do minus 3 once more, it will become minus 3. And that's less than 0, so that's not valid. So the result of this is 0. Well, let's do one more example, modulus 4. If we do 9 minus 4 minus 4, this will become 1. We cannot do minus 4 once more, because then the number is less than 0. It will be minus 3. So that means that the remainder of this will be 1. All right, but in our case, we want to do modulus 2, which means that if the number is even, so let's say 2, 4, 6, or 8, if we subtract 2 from those numbers, it will always result in 0. So that means if the total turns modulus 2 is equal to 0, we have an even turn. And what did we say below? If the turn is even, it means that the opponent is to play. The black pieces can play. However, if the total turns modulus 2 is not even, so this will be the scenarios where it is not even, this will be 1. Here we have also 1 and 1 and 1 as a remainder. That means that it is our turn because we are at the uneven turns. All right, so that's why we check up here at the modulus 2 is equal to 1. If it is an uneven number, the remainder, then it is a valid turn. Else, if it is not an uneven number, it is not our turn. So let's switch the statement up. If this is not equal to 1, and the team type is our, that is going to play. So if we try to play while it is not our turn, we say invalid turn. And let's do the same for the black pieces. If played piece dot team is equal to team type dot opponent, and the board dot total turns modulus 2 is not equal to 0. So if it is not, well, in our case always it will be 1, then what we will get is this, and that will be console.log invalid turn. And let's add a B for the opponent, and let's add a W for our turns so we can see what happens. Well, let's open up the console, and right now if we play with the black piece, it should throw an error, right? Yeah, invalid turn B, because it is not their turn. If we play with our piece, we don't get any logging, which is great. Now, if we move our piece, it works. And if we now move the black piece, we see that we still get a new log. If we remove the logs and we move with the black piece again, we still get the log. So it still says that the turn for the black pieces is invalid. How is that possible? Well, that is because we never update our total turns. When we play a move, we want to increment the total turns by 1. Which means that down here, where we set the board, which is here, we want to increment the total moves by 1. So we're going to, let's see, change the statement up a little bit. So in a previous episode, we have learned more about the clone method on the board and what happens if we modify an existing board. Just to be safe, we want to make a copy first of all, before we set the board. So we have clone board is equal to board.clone. And then right here, we want to say clone board.play move. And then down here, we say clone board.total turns plus is equal by 1. And then here we want to return the cloned board. Let's save this up and check if it is still working. Let's refresh the page. If we move with black, we get an invalid turn. If we move with white, it works. And let's actually move. If we scroll up a little bit, I'm going to close the console. We also see that the turn has been updated. We now have a turn of 2. You can run the previous code that we had and look at the turn timer above. It would never update to 2. It would always say it 1. But since we added this line right here, it will increment the turn by 1. Now let's open up the console again. And if we now move with the black pieces, we don't get an invalid turn. But if we move with the white pieces, we do get an invalid turn. Well, this is a really great start in order for us to implement this logic. However, if we now play with the white piece, it still ignores the console.log right here. As in, we can still play. That's not what we want. So in order for us to fix that, we can easily just say right here, instead of console.logging something, we say return false, because we cannot play the move. And we don't want to return that whole context. All right, let's add a comment to here as well. Prevent the inactive team from playing. And then it will be for those two statements. And then let's see, here we have the possible moves. Well, let's add a comment to here as well, so we know in the future what this was about. If the playing piece doesn't have any moves, return. Right. Okay, so let's try it again. If we now move with the black piece, we don't get to move. And if we move it at a spot where we should be able to move, we can also not move there. Great. So now if we play with the white piece, it works. And if we try to play with the white piece again, it doesn't work anymore. Great. this means that we have successfully implemented the logic for only playing with the current team. Almost, because right here we cannot take this pawn, and that was because it was not our turn. Alright, it's still a little bit getting used to, because previously we could just move all the pieces that we wanted. And let's see, right now we cannot move black because we have just moved black. Now we need to move white, then black, then white, then black, and then white. Yes, great. So the next thing that we want to do is we want to implement the logic that we have created in the previous episode for the king. So right here we see that this queen is blocking this whole vertical line. We can only move the left and right side. We want to implement that for the black king as well. So let's create a scenario right here where the queen is blocking this whole white row, and the bishop was also doing that. So, well, it's fine. And then if we take the king, we see that we can still move on those tiles, which is not what we want. We want to prevent this king from moving there because the queen and the bishop and the opponent are blocking it. We can only move here, here, or on those tiles right here. So these two tiles should be forbidden. First of all, let's go to the place where we determine if the king move is valid or not. And that will be in the board model right here. Now I'm going to collapse the bar on the left so we have a little bit more space for the code. And then down here, we calculate all the moves and we check the king moves. Okay, so here we have hard coded that the king that we want to check is the opponent king. This will not be the opponent king. This should be the king from the team that is currently playing. Alright, so the king from the team that is currently playing can be determined by the total turns. And what we want to do is we want to create a computed variable for this. So we have already created that once, and that is in the piece class. So right here, we have a computed function or a computed variable, if I'm calling it correctly. And right here, we have a function, is pawn, which returns a boolean, and it just returns something based off the logic. Let's copy this over to the board, and let's put it under the constructor right here. And instead of checking if it is a pawn, well, the board can never be a pawn, we want to get the current team, get current team, which will return a team type. And the current team can be determined by the total terms. So like if we go to the referee right here, we can say if the board the total turns modulus 2 is equal to 0, then it means the number is even. And if the number is even, that means that the opponent can play. So right here, we want to return this total turns modulus 2 is equal to 0. If it is equal to 0, that means that the opponent can play. So here we can say team type dot opponent. If it is not equal to 0, it is team type our. Alright, so this is an inline if statement, a ternary operator. This would be the same as saying if this dot total turns modulus 2 is equal to 0, return team type dot opponent. Else, if it is not equal to 0, we return team type dot our. So this, what we have right here, is exactly the same as we do right here. This if statement right here is this part right here, and then the brackets will be the, well, let's say the after the first question mark, and then the colon is the else, and then we have the brackets for the second else statement or the question mark. So right here we can remove this because we want to use this one-liner. If we save this up, we now have a variable on the board for the current team, and then we can use this to check if the king is the king of the current team. So we don't want to check the opponent team king, at least not always. We want to check the current team, and it should be this current team. All right, do we have any more hard-coded places right here where we check for the opponent team or our team? Because right now we have the king of the currently playing team. Well, if it doesn't have any moves we want to return, that's fine. Then we want to simulate the moves. Then we want to find a piece at the destination. Then we want to set the simulated pieces. We want to remove the destination piece. We tell the compiler that the simulated king is always present. That's fine. And right here we also have a team type.opponent. This should be this.currentTeam. And should it? Because right here we are using the simulator board. So this should be simulatorboard.currentTeam. All right. Then down here we try to get the enemy teams. So what we can do right here is we want to get the opponent pieces. So we want to check where the team is not equal to the current team, which means that it is the opponent team. We can simply do that by adding a bang right here or an exclamation mark to reverse the statement. So where it is not our current team, that means that it is an enemy team. Nice. Then down here we have the save. Here we have the opponent. So here we check, okay, if it is from the team that the king is in, we want to do nothing. That will be simulatorboard.currentTeam. Then down here we have something with the pawn. We have the check for the pawn moves. We don't do anything with the teams anymore, I think. Yeah, so that should be it. All right, let's test it out. I'm going to refresh the page. And now if we move the pawn right here, move the enemy pawn to here, we cannot move the king immediately. We need to move white first. We should be able to move the king to here, but then we can still move the king to those two places. So we have messed up something. I don't know what exactly, but we can still move here, which is not good. Let's see if it works for the white king. Maybe we have fixed that, but we have broken the opponent team's king. And we can also move everywhere. And well, if we look at this, now the move calculations are correct. So as you can see, it only updates it once we are at the white team. So if we are right here, now the white team is playing, and then we can see that the positions are correct. However, if the black team is played, if the white team is played and black is on turn, then we see that all the positions are not correct anymore. And then the white positions are correct. So I think we are calculating them for the wrong king. Hey, I think I found out where it went wrong, and that is that we increment the total turns after we have calculated all the moves. Because right here in the board, we call the calculate all moves method. And well, that calculates all the moves. But instead of this calculate all moves method, we use the current team, which is based off the total turns number. But the total turns number is only increased after we have played. So we can easily fix this by moving this before here. But we might want to rewrite that in the future. And let's try this again. If we now move the pawn to here, that pawn to there. We take our king, their king, our king, their king. We can move to here. They cannot move anywhere, at least only in the valid spaces, which is nice. And we can also move only in the valid spaces, which is really good. Let's move this to here, this to here. He can take the pawn. That's still something we need to fix, because then that shouldn't be possible. And he can also move to the left and right side. Oh, that's correct, by the way. I just realized, because we cannot play as black twice. Okay. We cannot take the pawn, which is correct. We can move to there, below. Let's do this. And then, well, he can take the pawn. What if we have the previous thing again? Now he cannot take the pawn. Great. So, well, I'll say it's working, right? We have successfully implemented the logic for preventing the king from moving into a dangerous place for both teams. So what's the next thing on the list? Well, it would be really cool if we could, well, let's say the turn is now for white, which means that we can move with white. It would be really cool if we could prevent the black piece, well, first of all, from being picked up, but that would be really cool. But first of all, let's try and prevent the dots and the circle from appearing, because now it looks like we can do that, but we cannot. So, well, it's false information, and we don't want it. We want it to be true. In order to do that, what we want to do, let's refresh the page. Once we start our game, we calculate the moves for both black and for white. And, well, let's see if it is white's turn, we don't necessarily need to calculate black's moves. In one way, we do need to calculate them in order to know if they can hit our king or not, but at least we don't need to display them. So if we open up our bar right here on the left and go to the chessboard, here is the logic for displaying the possible moves, I think. If we go down here, we render the pieces, and then we have this. Yeah. So this is all based on the possible moves. What we want to do is we want to remove the possible moves for the current playing team. Or, no, that's incorrect. For the team that is currently not playing. That's important. Alright, so once we start our application, we have a use effect, which runs on the app start, and it updates the possible moves, which calculates the possible moves from the board. Which is fine. Let's see what we want to do. I think is, we don't want to use this function because we will never call this. Let's see if we call this on multiple places. We don't. That's fine. Now we can remove this from here, and then we can do this. Nice. Okay, so right now we calculate the moves inside of this use effect. Let's see if it's still working. Yes, we can still move with both pieces, and then inside of this function, we loop through all the pieces, we calculate the moves, then we check the king moves, check if the king moves are valid, and then right here, we want to remove the possible moves for the team that is not playing. And this should be rather easy actually, because we want to say for const piece of this dot pieces dot filter. We only want the pieces that have the same team as the current. Oh, that's not what we want to do, as a current team, and we don't want it to have the same team as the current team. Let's see how we can make this small again. Great. So here we loop through all the pieces that are on the enemy team. Well, not necessarily the enemy team, the team that is not playing at the moment. And what we want to do is we want to say piece.possible moves is equal to this. Let's save it up. And now if we refresh the page, we see that we get no possible moves with black. And if we take the white pieces, we get possible moves. If we take the white piece again, we don't get any possible moves. And for black, we do. See, this is already looking a lot better. It looks a lot cleaner, and it removes any confusion, because now we don't get to think, hey, but it says we can move, but why are we getting snapped back? Great. So now that we have this working, we are going to add one more thing, and that will be this. Let me create a scenario right here, and then let's see, we want to move our king to here, and then the bishop to here. So as you can see, the bishop is attacking the king, but this pawn right here is preventing the king from being attacked. However, if we move this pawn away, the king will be in check, which means that this move right here is illegal. So we need to code, or we need to create some logic that prevents the pawn from moving here, or to remove the possible moves from the pawn in this scenario. Well, we also have other scenarios. Let's say we have the queen right here. Yeah, right here. And we have the horse right here. The queen is able to attack the king, but because the horse is in between, the queen cannot do anything. However, we are free to move the horse away, which means that the king will be left on his own, which is not good. So the horse should not be able to move away. However, this pawn should also not be able to capture the queen, since the queen is, since the bishop is targeting the king. Let's add one more scenario to here. If we move this pawn to here, then we move this queen to the left, king to the left, pawn, this one, pawn, king. If we now move this queen to here, we have to move our king to safety. We can move to here, here, or here, but we can also take the queen. Well, we cannot move up because the king is in danger. this move right here should be illegal, but we are able to take the queen, because if we take the queen, we eliminate the threat. All right, so let's start off by focusing on the first scenario, where we have the bishop right here, and that should prevent the pawn from moving up because it is protecting the king. Here on the left, we calculate the moves for all the pieces, and then right here, we check the king moves. What we also want to do is we want to check all the other moves that the current team is playing. Let's create a new function for it, and then if it looks a lot like the previous function, the king moves, maybe we can merge it, but for now we are going to create a new one, so we won't, well, let's say, create any complicated additions to the already created function. CurrentTeamMoves, and then down here, oh, we missed the T. We want to create a checkCurrentTeamMoves method, just like we did right here. And then what do we want to do? We want to loop through all the current team's pieces. So that would be all the pawns, all the rooks, knights, bishops, queens, kings. So we want to do a for const piece of pieces, this subpieces dot filter p.team is equal to current team. So then we have all our pieces. And then what we want to do is we want to simulate the moves. And now that I say this, we want to create a simulated board for that. So here we have all the pieces. We are going to add it up here. Loop through all the current team's pieces. And then what we then want to do is want to loop through all the moves. So right here, we want to simulate this move and this move. This move and this move. This move and this move. And then, for example, the bishop, it has a lot of moves. We want to simulate this, 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 and this move. Well, the list goes on and on and on. But you get the idea. We want to simulate all moves. So we say for const move of this dot moves. No, that's not correct. This of piece dot possible moves. And that might be null or undefined. Well, let's say if piece dot possible moves is equal to undefined. Let's just skip it for now. So right now we can say for move in piece dot possible moves. We want to simulate all the moves. Simulate all the piece moves. Great. So in order to simulate, we're going to create a simulate board is equal to this dot clone. And let's see how we did it right here. Yeah, great. And then down here, we want to apply that move to the piece. So let's say simulate board. No, that's not true. Okay, let's break it down to the pawns first. If we have a pawn, oh, we cannot move it anymore. If we have a pawn and we want to move, we want to simulate that move. And in order to simulate it, we just move the pawn to that position. So basically, the easy example will be to do this. We want to find the pawn on this clone board. So first of all, or not pawn, the piece. Const cloned piece is equal to simulate the board dot, and then it was find, I think. This we use the find method. Yeah, find. And then wasn't it the pieces? Yeah, simulate the board dot pieces dot find p dot same position, same piece position. We could also use as the current piece that we are handling. So now we have our clone piece, and then we want to update the clone piece. So we say clone piece dot position is equal to move dot clone. Here we get a null reference again. Well, let's say if clone piece dot position. Clone piece can be undefined. All right. Well, that's an easy fix because we know for sure that the clone piece will be on the clone board, because up here we already looked through the clone piece or to the normal piece. So we can remove this question mark, and we can, by the way, we fix this error by adding a bang or a exclamation mark at the end of the statement. in order to tell TypeScript that we know for sure that this clone piece does exist. As you can see now, the type is also piece. And if we remove this exclamation mark right here, the type will be piece or undefined. Well, we add it back in, save it up, and we update its position. So let's say this pawn is now right here. What do we want to do then? Then what we want to do is we want to check, is the king in danger? How do we check that? Well, that is what we already had right here. What we wanted to do is wanted to loop through all the enemy pieces. If that's correct, let's see right here. Yeah, so we want this statement down here. So we want to loop through all the enemy pieces for const enemy of clone board, simulator board dot pieces, and then p dot team is not equal to this dot current team, and then we also can say cloned board or simulator board dot current team for every piece inside of there. That will be the enemy, and this will be filter. We forgot that. So for every enemy, we want to recalculate their possible moves because we have just updated a piece position. So we want to say enemy dot possible moves is equal to simulator board dot get valid moves for that enemy, and then we want to add the board state. So simulator board dot pieces, like so. So this is basically the same as we did up here, I think. Here we also took all the enemies, we updated the possible moves of the enemy with the new board state, and here we updated the king, and instead of updating the king, we updated here the clone piece, which could be anything, but also a king. See what I'm getting at? We might want to merge this, but it's good if we type this out by its own at first, so we won't get any complicated mistakes. All right, so now we have all the updated enemy pieces or enemy possible moves. What we then want to do is, let's see what we did right here. Now I remember, we wanted to check this because the pawn can move forward, but that doesn't mean that it is dangerous for the king, because the king is only, well, in danger if it moves diagonally of the pawn. Okay, so right here we have all the updated enemy moves. Well, what we can do, what I was going to do was going to create a new loop to loop through all the enemy pieces and to check if the king is still safe, which is basically what we do above here. Okay, so little break. Right here we have the simulator board pieces, and here we update all the enemy possible moves. Okay, so we have updated our king position, and based on that position we want to update all the enemy possible moves. Then what we want to do is we want to loop through all the pieces. Well, that's not true. We only want to loop through the enemy pieces, because if it is a current team we want to continue. So basically those two lines mean exactly the same as this line right here, looping through only the enemy pieces. And then we have some logic. If it is a pawn, we want to do something else. If it is not a pawn, well, then it is not safe. What I'm thinking right now is we could put this inside of here, inside this for loop. Then we don't need those two lines anymore. So what we are going to do right here is, not this, is right here. We want to check if it is a pawn, and else if it is not a pawn. Okay, so first of all, if enemy dot is pawn, then we want to check, okay, if the enemy dot was it correct? Let's see. Yeah, and right here we are also updating the pawn moves, but we already have them right here, so I don't think this is necessary. Okay, so right here we are updating the pawn moves, but we don't need to because we already did right here. It's a little bit redundant if I look at it right now. So that's good to look back at the code and not just, you know, extend this function, but create a new one so we can refactor in the meantime. Okay, so we wanted to check if any of the pawn moves that don't have the same X position is the same position as the move. And now we don't want to get the same position of the move, we want to get the same position of the king. If enemy.possibleMoves.sum, so if there's any of them, I want to check the move, m.x, if the x position of their move is not the same as the x position of the enemy, that means that it is moving or horizontally or diagonally. And then what we want to do then is we want to do this, and the move has the same position of the white king, or well, in this case, simulator board dot current team king. So we still need to grab the king, and we want to do that right here. After we have updated the position, we want to say const cloned king is equal to simulator board dot pieces dot find p dot same position. Is it correct? No. P dot is king, and p dot team is equal to team type dot our. Is it correct? No, it's equal to current team. And then it will not be this dot current team, but simulator board dot current team. And then we will add the bank to here because we are sure that there will be a king. Okay, so now we have the cloned king position, and in 99% of the cases, this will be the same position as it had before, because if we move this pawn up one space, the king will remain in the same position, which means that the cloned king, well, is definitely the same as this one. However, once we get to the, we are looping through all the pieces, and once we get to the king, we update the king position, then the cloned king will also have the correct position. So that's why we need to get the position from the cloned king, which is really important. So now that we have that, we want to say m.same position, cloned king dot position. So if an enemy pawn is threatening our cloned king, what we want to do is we want to say safe is false. So we are going to create the same variable right here. Safe is true. Here we want to say safe is false, and then return. And that is only if the enemy is a pawn. Else, if it is not a pawn, then it is a lot easier, because then we don't need to check for the X location, because that basically just means if the enemy can move there, it's dangerous. If enemy.possibleMoves.sum m.same position as cloned king.position, then safe is equal to false, and we want to return. Is it correct? I think I forgot. Yeah, I forgot one bracket right here, or one closing tag. And then, well, let's see. At the end of that, we want to say if not safe, we want to remove that move from that pieces possible moves. So we say, oh, that's a good one. Here we have a reference to the original king. We don't have a reference to the original piece right here. Or do we? I think we do. It's the piece. Yeah. So then we say piece dot possible moves is equal to piece dot possible moves dot filter move doesn't have the same position as the current move, like so. Great. All right. Ooh, that's a lot of code with a lot of things right here happening. Well, we can remove the easy example because I think we have created it for all the pieces. Not sure though, but let's try it out, and then if it doesn't work, we'll check why it doesn't work. Let's comment out the king moves. Let's only work with the current team moves. Now let's move this right here, this one to here. Let's see if our previous situation was still working with the king. Well, not anymore. King can still move there. King can attack. Great. Okay. So let's see if we do this. We had a situation where we had the bishop. Let's take this bishop right here. And then we should not be able to move the pawn right here to the top. And that is working. Is it though? It was not our turn. Okay, it's not working. Yeah, so we can still move there. Okay, so something is not working entirely. In order to fix this, we are also going to explain the code. So we are doing two things at once. Here we have the checkCurrentTeamMoves, which is being called right here. And this function loops through all the pieces of the current team. Take the pawn right here. Let's create the scenario that we had. So now we have our scenario. In this case, it's about this pawn. So we look through all the pieces. Let's say right now in this if statement or in this for loop, we are currently at this pawn. If the piece doesn't have any possible moves, we continue. This one does have possible moves. It can move up. Okay. Simulate all the pieces moves. For every move in this possible moves, we are going to clone the board. We are going to find the new piece, which has the same position as our current piece. Okay, that seems legit, which means that we get this pawn in this variable right here. Then we want to set the position to the move that we want to play. Is that correct? Piece of possible moves. Yeah, so right now the piece is at this position right here. Then we have the cloned king. So we find the board, or we find the king on the simulated board that has the king, or that is a king type, and it is from our current team. Also fine. That's this king. Then we want to look through all the enemies, and that we can find them by, well, they are not the current team. Then down here, let's see. We get all developed moves based on the current board state. So that means when the pawn is right here, that should mean that the queen is able to zip right through the king. If the enemy is a pawn, well, this will be false because the queen is not a pawn. Else, and we go into this statement right here. If the enemy has any moves that have the same position as the cloned king, well, the queen should have, I think, because, or she shouldn't have. No, right, she should have. Is that correct? Yeah, she should have. I'm thinking that she shouldn't because right now we cannot move anything, but I think because we do this right here, yeah, we get, here it doesn't check if it is our turn or not. So that's great. So let's see where we were, right here. Save is equal to false, and we return. Oh, I think that's the problem. We return. We need to break. Oh, break. Okay, so we break out of it. And if it is not safe, then we'll say the possible moves on the piece is equal to the possible moves, where it is not equal to the same position. Okay, let's try it again. I think we have found our solution to the problem. We just needed to break instead of return. Can we still move up? We can still move up. It's the break. Right now, we are looping through all the enemy pieces. And if it is not safe, or if the move is not safe for our king, we set save to false and we break out of the loop. However, the checking for the save is inside of this loop. And if we break out of this loop, that means we will never update the possible moves. So what we want to do is we want to remove the save variable. We want to put the code that was inside of the save statement right here, and we want to remove the breaks, like so. All right, now if we save this up, refresh the page, and we move the pawn up, this pawn down, king, and queen, we should not be able to move the king to this space right here, because the bishop is attacking that. That's true. And we should not be able to move the pawn upwards, because the queen is attacking the king, is pinning the pawn actually. And as you can see, we cannot move the pawn up. Great. However, can we do any other moves? Yes, of course, we still can. Does this work with other pieces? I hope. Let's try it out. Let's put the queen to here. And as you can see, we can only move the horse to those two spaces, because that's the only way we can protect the king. We cannot do anything else. We can always move away with the king, but well, we cannot move to any place else with the horse. And now we cannot do that either. Great. But how about a scenario where we have our king right here, and then we have the queen. Let's see, how should we put this? We have the queen right here. The king is able to take the queen or move away. That's true. But the pawn should also be able to take the queen, which is not happening. If the pawn takes the queen should be eliminated and it should no longer be a threat to the king. So let's see, if we move the king to here, this pawn to there, this pawn to here, queen to there, queen to here. Can we still take the queen? We cannot, because this pawn is guarding the queen. However, this little piece of information is still missing. How can we make sure that we can also protect the king by slaying the queen? In order to do that, we look through the code that we had up before, where we removed the piece at the destination, because that's what's going wrong, I think. If we move the pawn right here, the queen should be removed, and then the queen is no longer a threat to the king. So down here, where we have cloned the piece position, before we have cloned the piece position actually, we want to remove a piece that is already inside of there. So if simulate the board dot find pieces dot find, and then we want to find the piece that has the same position as the move. Is it correct? No, we need to add one more. Yes. Then we want to say simulate the board. Let's see. No, we are going to store this in a variable. This right here will be named piece at destination is equal to that. And I want to say if piece at destination is not equal to undefined. So if there is a piece at destination, we want to say that we want to remove that piece. How did we remove it? We filtered the board. Let's see, what we could also do is something else, but I'm going to show you that in a second. For now, I want to say simulate the board pieces dot filter p dot same position as the move, and we don't want them to have the same position as the move. We are first going to add one additional thing, and that is we don't need to store this in a variable and then check if it's undefined. We just want to say to the simulated board, hey, we don't want to have any remaining piece at the destination position like this. Of course, we need to assign the pieces to that filtered array. Like so. Let's try this again. And as you can see right now, finally, we can save the king by slaying the queen. Yay, great. All right, so now that we have this fixed, what we can do is we can remove the method that we have created before, because this one is commented out and it still works as it should. We can also remove this one, and instead of saying check if the king moves are valid, check if the current team moves are valid. Well, this should be fine, I think. Let's add a couple more comments to the code right here. Remove the piece at the destination, location, position. Then here we want to get the piece on the cloned board. Down here we want to get the king on the cloned board. Let's say off the clone board, because we want to get the piece which is from the clone board. And then down here, loop through all enemy pieces, update their possible moves, and check if our king, or check if the current team's king will be in danger. Dot. Without dot. All right. So, well, this will be it for this episode. I want to thank you for watching. I hope you could follow along. Leave a like down below, comment, share, subscribe, and I'll see you in the next episode. Bye.